Welcome to this online training on how to migrate from Nios II to Nios V processors. Feel free to pause, move forward or go back as you need during the presentation. You can find the control bar at the bottom of the course screen. You will find resources and links that are related to today's training in the section at the top right. On the left, you will find the outline for the slides. Feel free to navigate them as you need. Let's get started. The Intel FPGA portfolio supports this transformation, including discrete and integrated FPGAs that are expected to improve processing efficiency, task specificity, and connectivity. Intel FPGAs can provide a variety of workloads in network processing as well as compute and storage acceleration. FPGAs are mass-produced, standard product ICs that can be reconfigured in the field to accelerate virtually any digital algorithm. They offer greater throughput, execution speed, and energy efficiency than CPUs on computationally intensive parts of algorithms, but with the ability to adapt quickly to changes in algorithms, data patterns, or performance needs. They can be reconfigured in the field to accelerate virtually any digital algorithm. They are available in 5 current families: Max, Cyclone, Aria, Stratix and the newest family Agilex, all with of increasing capacity, performance, and feature sets. The objective for today's course is to review the characteristics for Nios V processors and provide a guide of the tools and advantages of migrating from Nios II to Nios V processors. The agenda topics for today's training will be highlighting differences between Nios II and Nios V processors' features and tool migration, Nios V processors' description and architecture, as well as hardware and software considerations when migrating from Nios II to Nios V. Nios V processors are Intel's next-generation soft-core processor based on the open-source RISC-V instruction set, designed for Intel FPGA devices with support in the Intel Quartus Prime Software Pro and Standard Edition from version 21.3 and further. Currently there are 3 versions available for Nios V supported with different applications. Nios V-M processor with microcontroller suggested use, Nios V-G processor as a general-purpose processor with custom instructions, and Nios V-C processor as a compact microcontroller. Additional to the underlined features, there are also shared characteristics among all IP, which include 32-bit general-purpose register, debug module, machine mode, interrupt controller, exception handling, Intel HAL, Micro C, OS 2. Debug module is available for Nios V-M and Nios V-G. For more information on the features and comparison among all IP for Nios II and Nios V processors, you can take a look at the migration guide in the resources section. The ecosystem to support Nios V projects uses Ashling RISC-free IDE for Intel FPGAs, which is also an Eclipse-based IDE, as well as different OS support and debug. Notice that for Platform Designer use with Nios V processor you just need to replace the IP since it has a similar interface than Nios II. One of the main differences in the Nios V design flow is BSP generation that can be done from the command shell or as an embedded feature inside Platform Designer. It used to be a feature used in the Eclipse IDE for Nios II ecosystem. To migrate from Nios II to Nios V, you need to consider BSP file generation and its import to Ashling RISC-free IDE for Intel FPGA's project. You can apply different commands for BSP generation or through the editor in Platform Designer. To generate the app folder for Ashling RISC-free IDE for Intel FPGAs and Nios V, you can do it through the Nios V app utility. Then import the app folder to build the project. You can go through the whole design flow using the tools or Nios V command shell to regenerate your designs once the Nios V design is migrated. The discontinuation notice for Nios II is in our website for upcoming devices and Intel Quartus Prime software newer versions. If you want to know more, go to the suggested link in the resources section. Some of the advantages of Nios V processors include RISC-V open community and huge ecosystem and support. Wide ranges of operating systems supported. No need to install WSL. Ashling RISC-free IDE for Intel FPGAs supports different capabilities for debug and software build bundled in supported Intel Quartus versions. To know more about Ashling RISC-free IDE for Intel FPGAs, you can read our user guide provided in the resources. This is the list of functional units that both Nios V-M and Nios V-G have as part of their architecture. Additional to the previous units mentioned, these are the features supported with Nios V-G processor. On the right you see highlighted the differences for Nios V-G processor core. Remember that the Nios V-G processor is a general-purpose processor that has custom instruction logic, instruction cache, data cache and a multiply and divide unit. Nios V-M processor core, which is a microcontroller, has the architecture shown on the left: program controller and address generation, exception controller, ALU, general purpose registers, control and status registers, as well as a load and store unit, a timer and software interrupt module. Notice in red the debug options. The option with Nios V-C being a compact microcontroller is the small Nios V version with non-interrupt driven control application. The Nios V-C has the following functional units: arithmetic logic unit, general purpose register file, instruction bus, data bus, ECC module. Here we find a suggested mapped migration from Nios II applications to Nios V processors along with the Intel Quartus Prime Pro and Standard editions. Remember that versions supported vary in each Intel Quartus Prime software version. Consider device support and IP for each edition and version. Before moving to Nios V, consider the design for performance, architecture and functional blocks needed. This will help you decide the processor version needed. The type of project and design will help you decide. For example, if the application is bare metal, RTOS with interrupts, basically you can use all existing Nios V cores. The flow to generate a file for the FPGA are parts that can be customized by the user. It is important to note that before programming the FPGA there are steps to be done during the software flow that happen in between BSP generation and full compilation, like hex file generation or CMake creation. Start by opening an Intel Quartus project and then go to Platform Designer in the Tools menu. This will open an existing QSys design, or you can create a new one. Then you can import from the IP catalog the Nios V processor for your design. Once you decide on the type of Nios V processor, you can start your parameter configuration and the elements you need for your design. This file is the central component of the software project. Describes all the components of a software project and how they are compiled and linked. The CMake lists.txt compiles the source code and links it with a BSP file and one or more optional libraries to create one .elf file. You can invoke the BSP editor from Platform Designer to configure the files for the project that need to be generated. You can also do this from the Nios V command shell bundled with the Intel Quartus Prime installation. This used to be a Nios II command shell or done through Eclipse IDE. Several options for customization are available for the BSP editor. As mentioned, the Nios V command shell provides a way for different tools and tasks for the development during the whole design. You can invoke also Ashling RISC-V IDE for Intel FPGAs from the command shell. Once it opens, it will prompt you for the workspace directory. Once the workspace is launched, you need a C++ project. Select the type of project and click on Next. Continue with the windows for project creation. Assign a name to the project. The location for the project must be routed to where the cmakelists.txt file was created, app folder inside the Intel Quartus project. Then select CMake-driven, empty project, CMake-driven, on the right, then click Finish. Notice the structure of the project created includes .elf files, cmakelists.txt files and the application. This is a summary of the Nios V command line tools and tasks which you can use for some functionalities and file generation with the Nios V shell. To consider if you want to change your design in Intel Quartus Prime software step by step, go to Platform Designer and open the design you want to migrate. Go to the IP catalog search and select a variant from the catalog. In Nios II you had inside the same window both options. Now with Nios V you can select from the catalog directly which option to add. You can see the example on the right. You can directly substitute the Nios IIe processor with the chosen option for Nios V. Here we see it being substituted for Nios V-M. Once the Nios V processor is added to the system, you will notice that you have one key difference, that is the internal timer. Instantiate and connect accordingly to Nios V to adjust the whole system in the new design. This case shows Nios IIF substitution for Nios 5G processor, where also the signals are being connected accordingly. Notice the instruction manager in both cases and the differences in the name conventions. The suggested mapping if you previously used Nios IIe is to substitute and configure in your design Nios 5 CIP component. It is important to notice that there are steps that need to be regenerated in order to migrate from Nios II designs to Nios V designs, since once the integration in the Intel Quartus Prime project and Platform Designer is done, the rest of the tools used for the software components of the project are generated using different tools than what was previously used with Nios II. For example, BSP generation, app and ELF generation, as well as the use with Ashling RISC-V IDE for Intel FPGAs. You can find examples and resources in the design store inside our Intel.com search to get started with Nios V processors. These are some of the links for resources that include websites for the design handbook, reference manual, migration guide, as well as download center for Intel Quartus Prime software and Ashling RISC-V IDE for Intel FPGAs, Nios II embedded IP release notes, and the self-service licensing center. Intel provides multiple avenues in which to learn about Intel FPGA products. There is the Intel FPGA YouTube channel, which contains 5 minutes quick videos along with longer, more in-depth training videos. There is the Intel FPGA training website, where you can access e-learning courses made up of narrated slides presented in an interactive player, some courses with labs and demos. Lastly, you can also enroll in a live, instructor-led course presented either in person at an office local to you or virtually over the web. All instructor-led courses have hands-on labs exercises to practice the concepts you learn. If you need more assistance, Intel FPGA provides many self-help resources for you to access. For example, there are web pages, called landing pages, dedicated to specific FPGA technology and high-speed interfaces. You can also view and post questions to the community forum, which is monitored by skilled Intel FPGA applications engineers. The Intel FPGA training team is always looking to improve our material and welcome any feedback you may have. Please email fpgatraining@intel.com with any of your thoughts or comments. This concludes the training. Thank you.